Good afternoon. Today I'll be speaking about TCG enhancements that we are doing in PowerPC. My name is Nikunj A. Dadhania. I work for IBM Linux Technology Center. Something about myself, I'm primarily the guest firmware developer for pSeries called SLOF. Initially, I started somewhere around 2012 developing SLOF, and I was like, I had to debug SLOF or test SLOF. So the thing, at the time, the KVM on power was not even available. So one of the issues that I had was how to develop SLOF, and QEMU TCG was very helpful during that time, and I've been using QEMU TCG for quite a long time. So, as a QEMU user and trying to do something in TCG as well. So the agenda. So we would basically touch upon quickly on the QEMU TCG part. After that, I would cover the new Power ISA 3.0, which is upcoming in our new processor, Power 9. The next topic would be PowerNV. This is basically the bare metal emulation of the Power hardware. Some experiments that I did with multi-threaded TCG, will cover that, and some of the optimization and future work. So let's start with QEMU TCG. So how is emulation done? So if I have a PowerPC machine code, I'll have a stream of instructions, and basically I will need to translate it onto the host where I want to run. So basically it will be like, if it is x86, I would just convert that instruction stream into an x86 code, and then I'm able to run on x86. So it is easy to do for maybe like few instructions, but if I look at the ISA is huge actually. So it will be hundreds of instructions. So basically it's one ISA to the other ISA conversion. So if I have multiple architectures, basically I need to translate from various architectures to x86, and then I will run on x86. And this really gets complicated with multiple n cross n kind of scenario where I want to run Power on x86 or ARM or something like that. So TCG here helps a lot. So the QEMU TCG with the tiny code generator basically gives us a machine-independent intermediate notation. So basically, architecture developer just needs to encode in microops, and finally, whatever backend support is there, I can run Power on any backend which is supported. So this TCG engine can be combined in different ways to give us something. If I combine it with a Linux system called emulation, so what I get is basically QEMU Linux user. So I would be able to test my Linux programs using that. Target program on a foreign architecture actually. So the QEMU avatar is Linux user actually. So what do I input? I input the target binary and the libraries. It provides me the Linux system call emulation, and it emulates the ISA. So this basically can be used for debugging user programs, and I have been using this to test the new ISA 3.0 unit testing, basically the newer code that I am writing. So with this short primer on TCG, let us start looking at what do we have in Power ISA. So the newer ISA. So the ISA comes with a lot of instructions actually. So the newer ISA has around more than 180 instructions, and there are various classes of instructions that are added. There are in atomic categories, then hashing support. There are a lot of string operations that we can optimize, reading string, many little Indian, big Indian kind of scenarios where a load would generate the consistent memory layout. So the standard is open now, and we can actually download the standard from the link that I have provided. So we have been like publishing patches for Power ISA, and we have around 24 queued up in the PPC tree for the next 2.8. We have basically started from the arithmetic and the vector instructions. There are many under review, basically a load store kind of instructions that are load store vector scalar. In TCG, we don't have 128-bit loads actually, so we are finding trouble there. We have to split the load into two things and do it. So that would be something that we would like to add as well. There are many instructions that I have under testing under the so that's the link that I have. That's a working link that I have right now. So the work in progress for P9 TCG. So the challenges that we see here is the testing. So we have like huge number of instructions that we are adding here, and some of the instructions do change something retrospective as well, because there are some new bit fields, the carry fields that they have updated. So the older instructions, the do or multiply instructions, would change, would have to start changing the 32-bit overflow flags as well. So testing is one of the important things that we are seeing. There's a gap there. So we have been talking, and there are different options there. One is use KVM unit test, basically to make sure that we add for every instruction that we are adding, we add a unit test there and make sure that different kinds of invalid test cases, then valid test cases, overflow conditions we can do. One of the idea was using QEMU Q-test. The first one, QEMU unit test, I tried doing hacking up and adding a few things, so that is simple, but I'm not sure about Q-test. I have to still look at that part of it. The last one is Anton Blanchard has basically written a fuzzer. So it would be something like Sagar explained, I guess, in the previous talk, wherein like we have a real hardware, Power 8 hardware, and QEMU TCG Power 8. So we run the stream of instructions on Power 8 real hardware and the stream of instruction QEMU TCG, compare the results, and we could find whether they're correct or not. The thing is, we still don't have Power 9 hardware, so we can't do testing for this. So that is one thing. So the next thing is the PowerNV platform enablement. So till now in QEMU, what we have is basically the guest emulation. So Power would always run in guest mode. So PowerNV stands for non-virtualized. So this is the new machine model that we are adding, and system emulation, I think everyone knows, but let's go through it. So the system emulation, the same TCG engine, when I combine with the emulated devices and the soft MMU, along with the guest firmware, what I get is basically the new QEMU Avtar called system emulation, whereas like I can provide a machine, whatever kind of machine that I have. It runs. It can run various different VMs in its own isolated memory, and I can use that NTCG mode to debug my firmware. I can debug the kernel. So this is what I was talking about, the pSeries machine emulation. So the current QEMU support that we have is for pSeries machine emulation, wherein we have the TCG combined with SLOF, the emulated VIO, MMU, and the interrupt controller emulation, plus real-time abstraction layer. So this all combined gives us a pSeries machine emulation. So this is basically based on the PAPR standard, which defines the hypervisor to the guest interface. So the pSeries is basically hypercall based. So this has been there from last few years. So the new thing is the PowerNV machine. So it basically emulates the bare metal power. So and along with that, we need the bare metal also has the BMC, the board management controller, the IPMI. So we need support for those things. We also need to support hypervisor mode actually. So till now, as it was running only only as a guest, so we never had support for hypervisor mode in TCG system emulation. So the PowerNV patches adds the hypervisor mode. It can run nested guests basically, so it can be in HV mode and maybe who knows PR inside HV. So we can have 3 levels of means 2 levels of nesting on top of this. So it basically assists in the early bring up of the hardware. So before we actually get the systems, we can use PowerNV emulation to do all our driver testing. Yeah. So the status right now is this was initially done by Ben Herrenschmidt, and our engineer for France called Cedric is basically developing, pushing the patches. So the around like 50 patches of our preparatory work for PowerNV is already in some stage. Either it's upstream or it's in David's tree actually. So as I said, we added hypervisor special purpose registers. We split the instruction and the data caches so that we have better performance. TLB flushes basically what used to happen was there used to be TLBIE and SLBIE, and that used to come in batches. So if we go and do a TLB flush every time, so it will be like mem clear maybe 10 times or something like that. So we batched them together, and then that improved the performance of booting the guest. XICS rework. So because we are adding the native model, we need the native interrupt controller support. So that rework, some portion of his upstream and some of them are still pending actually. So, yep. So this is something that I tried. There are patches floating around. Alex Benny had some enablement for multi-threaded TCG, and I thought that let us give it a try. So to explain how current system emulation work is basically we run multiprocessor. We can actually start a guest with multiple CPUs, but all the vCPUs are going to run serially, and the emulation would happen serially. So we cannot basically do the concurrent emulation. Basically, we will not end up in a situation of deadlock or something like that in this kind of scenario. So the multi-threaded TCG basically brings this feature wherein like we can run vCPUs in each CPUs, and then basically we can do the multi-core bring up, which would basically we can find out issues much before we actually go on to the hardware, right? So for PPC support, I based on his latest patch series V4 with atomic compare exchange patches, and pSeries basically we have HCall based virtual machine. So the HCall can actually return, which can actually do I/O as well. So we had to take I/O thread log for every HCall. PowerPC has load with reservation and store conditional, which is used for atomic instructions. So we had to write those. We had to change those instructions basically to use our atomic compare exchange micro-ops. So I was able to boot a VM with 4 vCPUs and did some testing with single-threaded. So I used to get single-threaded runs with 4 threads was something like this, and the multi-threaded that I ran was like around 3.5x kind of scenario. So, okay, the problems is it's still unstable. That there might be some issues that related to power or that I see because we have the page table is owned by the hypervisor actually. So we need to a TLB flush would come as a hypercall, H remove or something like that, and it can come for one entry or it can come for bulk of entries. So when that comes, I have to make sure that all I remove them from all the CPUs. So I have something working, but it's still not functional yet. So the other problems that I think could be memory barriers, because of which I'm seeing some crashes. And next would be the current thing that I hacked was basically the pSeries emulation. So next would be to support PowerNV platform as well. So moving on to the next thing is basically, okay, so there are multiple things that were posted. So Ben Herensmith is mostly doing a lot of surgery in the TCG area of power recently, and there are a lot of load store improvements that he had done. And then there were issues with exception handling, so he has improved that. I have started doing the load store consolidation. So Power did not use the QEMU load store micro-ops. So the newer micro-ops rather, I would say. So I'm doing that consolidation. So moving on to the next slide. Yep. So future. So we have a lot of instructions that we need to add. So that's a big piece of work that we need to make sure that we can get in, and then testing those instructions is one of the things. Upstreaming PowerNV is an ongoing thing, and I think maybe by in 2.8 mostly we can get all the patches in. Future PowerNV support. So we would like to have the system emulation of Power9 available so that we can do the testing early. Stabilize MTTCG that I was talking about back, and 128-bit load store support in TCG in some way. If you can get that, the load store and the vector loads would become very simple for us. Right now, what we do is we do a lot of this in the helper routines most of the times, and which would be slow, and it's tedious to write those things there. And yep, testing mechanisms. So, credits, yep. So Ben Herensmith. So I'm representing work of Ben and Cedric here as well. Thanks to Alexander Graf, he has a very nice presentation on TCG, and Alex Benny's toward multi-threaded TCGs that he presented last time. So with that, I think, yep, that's it. Questions?
Hi. First, I have a small comment. My name is Alexander with an E.
Is that okay? Yeah. Sure.
And then have you heard of Risu?
Okay, I'll do that. Yeah, I actually you told that in his talk. So yes. RISU you said, right?
RISU, yes. That's Alex's baby, basically. It's Peter's baby. Well, it's both of yours, right? Like you and Peter together is, yes. So we used it when we did the AR64. Come to the mic so it's recorded.
So, I mean, it sounds very much like the instruction Fuzzy mentioned, but basically we used it when we did the AR64 implementation, and it does a similar thing. You give it a bit pattern for a set of instructions, it randomly generates the instructions, and then you run it on something that you know is good, and compare the trace with your emulation.
Okay.
The problem, as you noted, is you need some hardware that you know is good. So when we first started, we were using the ARM Foundation model, which we knew was valid, and then we were testing against QEMU, and then when we finally got hardware, we did that. But it sounds like the instruction fuzzer does a similar sort of thing.
Okay.
Whilst I'm up here, I want to bet the problem with Qtest, which is a general problem we have for testing anything that's TCG related, is when you want to compile stuff for a foreign architecture so you can test on the host architecture, it gets tricky because you either have to assume what the cross-compiler's called or test to see if there's a cross-compiler there. And it just doesn't work very well, okay. So it tends to bit rot. But there are some potential solutions we're looking at. So you can build a Docker image with Linux user, and then maybe we can set something up to do a cross-compilation that way, but no one's actually got that working yet.
Okay.
Anyway, sorry.
Okay. Good. Sure. Thank you.